Hello friends, in today's question, a glass capillary tube is of the shape of a truncated cone with an apex angle alpha so that its two ends have cross-section of different radii. When dipped in water vertically, water rises in it to a height h where the radius of its cross-section is b. If the surface tension of the water is S, its density is rho, and the contact angle with the glass is theta, the value of H will be, and G is acceleration due to gravity. So we are given a capillary tube which was in the shape of a cone and it is truncated. So we get that water is rising from the bottom to the height H, and we have to find out what will be the value of H in terms of S, rho as well as theta. So let us draw the diagram in a more elaborated way. So this is truncated cone. So let us draw a truncated cone. It will be something like this. And let us suppose the water rises up till here, so the shape of the water will be something like the curved shape, and this is the axis which passes through the center. So we consider a point P, and let us join this also. This point is our O, and let us join this, and we call this as point as Q. So we are given that the angle of you can say apex angle is alpha, so this angle will be our alpha, so therefore this angle will be our alpha by 2. So there will be various forces that will be acting at this point. So let me redraw this, especially the triangle part, separately, and we will discuss all the things relative to it. So we have, this is point P, and we have a point O, and this is our point Q, and we have, it will be joined like this, and we get alpha by 2. Let us draw a vertical parallel line to this vertical axis, calling this as x prime. So this angle will be our alpha by 2, and let us extend this wide other edge of the cone in this way, and with the vertical this angle will be coming as alpha by 2, and it is given that the angle of contact is theta. So let us, I forgot to draw this is our curved shape, and let us draw something angle of contact. This angle is given as theta, and we are going to have surface tension which will be acting in the along the tangent, and this will be our angle will be coming as theta plus alpha by 2. This angle will be theta plus alpha by 2. I think more or less we have drawn everything. We will figure it out what everything is left. Okay. So we know as soon as this glass capillary tube truncated cone is dipped in the water is going to rise because of the surface tension to the height h, which is mentioned and which we are supposed to find out. And this is our level h. So we say when the glass of fine bore is dipped in the liquid rises immediately to a certain height due to surface tension. Liquid rises immediately to a certain height due to surface tension. Surface tension. And this liquid column is going to exert a force that we can call as S per unit length along the line of contact, and that is at the angle of inclination theta, and we can say R is the radius of capillary tube. Yeah, I mentioned figure 2. This will be our R. So we can say that the liquid column exerts a force S per unit length along the line of contact, along the line of contact at an inclination angle theta and we can also say that R is the radius of the capillary tube. R is the radius of the capillary tube, in this case cone. So we are going to use this triangle. In triangle POQ, we are going to find out the, you can say, yeah, this is, let us suppose, taken as B. So we say in triangle POQ, in triangle POQ, cos of theta plus alpha by 2 will be equal to B upon R. Now there will be two forcing acting. One force will be the buoyant force and the other force will be because of the surface tension. You can say two forces are acting. First is buoyant force. Let us suppose that is Fb, and that will be given us as pi b square, and we have h rho g. And the second force will be our force due to surface tension. Force due to surface tension, let us call that as Fst, and which will be equal to S multiplied by 2 pi b, and we get this cos of theta alpha by 2. And in equilibrium, Fb will be equal to Fst. We can say that at equilibrium, Fb is equal to Fst. So simply substitute the values, we get pi b square h rho g will be equal to S 2 pi b, and we have cos of theta plus alpha by 2. Pi goes with pi, b square cancel with b, and yeah, more or less. So from here we get h will be equal to 2s divided by b rho g, and we have cos of theta plus alpha divided by 2. So this is the value of h, and the options that are available to us is our option number theta plus alpha by 2 is D is the correct option. You can say option D is correct. Option D is correct. Excuse me. So this completes the question. Thank you.